Hi, today we're going to be flashing the Meraki MR18 with JTAG. There's already a process for flashing the MR18, but this one uses serial. Today we're going to be using the USBJTAG NT. Now there's already a video on how to do this, but I'm going to expand on that video a bit more because we're not going to be using the script. We're going to be doing the process manually, step by step, so you guys can get a better idea of what's going on underneath, okay? So what you're gonna need is you're gonna need a USB JTAG. You can get one of those at USBJTAG.com and I think shopping. And also you're gonna want to go to USB JTAG, the menu, and then USB JTAG NT, and we're gonna want to go to the devices and we're gonna search for the MR18 here. So we search for Meraki MR18. Here you're gonna find some pictures. You're going to find a video, which I'm going to be expanding on this video, and you're going to find this zip file that I want you to download, and you're going to get it. This is what you're going to get. You're going to get a USB file and an XML file. These files you're going to extract, and you're going to place those in your app data, roaming, USB JTAG, and then the XML is going to go in config. It's going to go right here. And the script, the USB file, you're gonna want to put it right here in scripts. So once you've done that, we're not gonna use the script today. We're just gonna need the XML. Once you've done that, I want you to launch your USB JTAG NT software, and then you're gonna go to config. You're gonna go to router, eJTAG, and you're gonna see the MR18 right there in the options. Or you can do a search for MR18. And it's gonna show up right here, and you're gonna select that, and this is what you're gonna get. You're gonna get the boot, kernel 1, kernel 2, UBI 1, UBI 2. This is not actually UBI 1, and this is not actually UBI 2. This is actually the UBI and CalData folder, the CalData partition, all in one big, lump. But it's actually divided in two parts. I'll explain why later. And you got the all flash, which is going to display, the whole entire flash of the router. Okay. So we've got the JTAG NT software. What else do we need? We need, if you guys are not, too keen on soldering, you can use this solderless pin header, which is actually only a 10 pin. The USB, the MR18 has, and the USB JTAG have a 14 pin, but you're not going to need all 14. We only need actually 6 of these pins. So you're going to need the TRST, TDI, TDO, TMS, and TCK, and one of the ground pins. So that's all you need. You don't need anything more than this and your USB JTAG NT. Okay, also, I've downloaded the final version of the MR18 firmware from GitHub, from Riptide Wave. See right here, I've downloaded this and I've extracted it, but you're not gonna flash this or this yet. What you're gonna do is you're gonna flash this file, which is actually this file here, but I've already flashed it to the MR18 and I've extracted it. Now it has extra data on there, so we can only flash the ECC file. You cannot flash the raw kernel. This has some ECC code in here, the error correction code, and this is needed for NAND to in case of data corruption or whatever. It uses this to do recovery and stuff. Recovery and stuff. So we need those, and so now what we do, first thing we do is we're going to connect everything. I also have a serial, connected to the USB JTAG, which you don't need for this, but I just have it connected to show you guys what's happening in the background. So first we're going to launch the USB JTAG software. Or we're going to plug everything in. We're going to connect everything, everything via USB. You can see right here the USB JTAG is connected. My serial is running, everything is connected, but the MR18 is power off. So I want you to, before you power it on, you're going to type program right here. This is going to halt halt the boot process from the MR18, which you're going to see stop right here. So you're going to type program, you're going to be ready. Then what you do is you plug in your MR18, which is I'm going to do right now, and you count to 1 and you're going to hit enter. So I'm going to plug it in now. I'm going to count 1, hit enter, and boom. As you can see right here, that stopped the boot in its tracks. So you can see right here, the boot started and it stopped right here. So now you're going to look here, and if you see trap on, then you know you've done it, correctly. You see. So now we are able to detect. So you can come here and you can type detect, or you can click up here and click ID, which is also detect, and it's going to detect. So if you see this output, then you'll know everything is is peachy. Okay, so now we've detected the chip. Everything looks good. So now first thing we do after that is we read the chip. So this is going to take a while. It's going to take about 10 minutes. And so you do get RAM 0. You can do that. You can type it down here, but we're going to do that. So right now it's reading the entire chip. So you can see it's populating right here. You see it's got the boot already, the kernel 2, not yet. And so we wait for this to read the entire chip. What's good about this is we are able to save an exact copy of our entire flash that we can either use to debrick or come back to if we ever wanted to come back to it for some reason. So we're gonna let this complete, and I'll be back when it does. Okay, so that process has completed. Okay, so now we've read the entire content of the flash drive. It took about 10 minutes 36 seconds. It's relatively fast. Now what we can do is we can save this, and we can use this in the future. So we click the save icon right here, and I'm going to save it right in this folder right here. I'm going to call it original Cisco, because it has the original Cisco firmware on there. And also you can save the individual parts of the firmware. We can just save the boot. So we're going to save this and call this boot. And we're going to save kernel 1. You just select the tab and you click save, and you go kernel 1, and let's say Cisco, and kernel 2, which is the same as kernel 1, Cisco. And we're going to just verify that kernel 2 and kernel 1 are actually the same. We're going to compare those. Yes, they're actually the same exact, firmware, everything. Everything's the same. So we just need one. Okay, so we got boot, we got the kernel. So now what we have to do, we got the original backup, which we can use later. You notice it's 132 megabytes. Okay, so what we're gonna do now is kernel 1, we're gonna erase this. So the way you do that is you select the tab for kernel 1, and then you click up here and you click erase. Or you can type erase down here. So we're gonna erase. Are you sure you want to erase? Yes. So now we go to kernel 2, and we're gonna also, now what we're gonna do is we're gonna erase this. Yes, let's erase it. And now we're gonna flash. We're gonna open. So you select kernel 2 and you click open. And we're going to select the ECC version, which is of the raw. So we're going to select this version, the ECC, not this one. We're going to select the ECC version of 1.0 final, and we're going to write this onto the NAND. So we're going to program this. Make sure you want to program. It's going to erase again, and then it's going to reprogram. So that erase I just did was probably meaningless. Okay, so by erasing kernel 1, it's going to force the bootloader to boot from kernel 2, which is now the OpenWRT image. And once we've booted into kernel 2, from there we're going to flash the sys upgrade. Same as, same process as in the serial tutorial that Riptide Wave has. Okay, so now we've finished. It says yes. It says it took it actually took 2 seconds to program. This is it actually copying the data over, but actually to write the data it only took is that 2 seconds or 2 milliseconds? I don't know. So it's pretty dang fast. Anyway, okay. So now that we have that, we're gonna actually power off the MR18. I'm gonna unplug it, and now I'm gonna plug it back in. You're gonna see it start up on the serial side over there. You're gonna see that start up again, and it's going. And we're gonna launch a web browser, and we're gonna wait for the boot up process to complete. And looks like it's almost there. I think it's done. So now we're gonna log into the web UI 1.1, and as you can see now we have the MR18. We're gonna log in as root without password. You can see we have the MR18. This is the Inet RAM FS ECC version. It's the same as the 1.0 final, and you can see it's already installed. Okay, now what we do now is we go to backup flash and firmware. And what we're gonna do is we're gonna flash the sys upgrade version. Before this happens, I'm gonna do an extra step. Okay, so what I'm gonna do is I'm gonna reformat the UBI partition to give us more software space. Okay, so the way you can use the serial to do that from right here, but I'm gonna go and I'm gonna show you that you don't need serial. You can do it with SSH. So what I'm gonna do is I'm gonna SSH into the firmware into OpenWRT 168.1.1 port 22, and I'm gonna log in as root. Let's bring this over here. Say yes. Log in as root. No password, and I'm in. Okay, so that's the same thing as over here, but you don't need a serial port actually. So you can do this everything via JTAG. So what I'm gonna do is ubinfo-a. This is going to give us all the different UBI partitions. And we're going to delete everything except the board config. Okay, so we're going to go down the line here. So we're going to go, hang on a second, let me get those commands. Okay, so I found what I was looking for. Okay, so first thing we did is ubinfo-a. It's going to give us a list of partitions that we're going to delete. So now we're going to use this command right here, ubrmvol/dev/ubi0 uppercase n, and we're going to use the names that we copy from right here. So we're going to delete cal data first, and that's gone. And we're going to delete diagnostics 2. I'm sorry. We're going to delete diagnostics 2, and we're also going to do diagnostics 1. That's diagnostic, by the way. And also we're going to do the same for the root FS, and it has the firmware version. So this is what firmware I'm currently running with -2, and there's a -1 as well. So we're going to delete that one. Let's do the 1 first, and we're going to do the 2. And this is going to give us this is going to nearly double our space that we have on our software, storage. Okay, so we got storage. Yeah, we got storage now. We got to delete. And this is the final thing we have to delete. And that's done. So you can see right here, this one is actually, you can see the size right here, 8.3 megabytes, 8.4 megabytes. 20 megabytes, all that space we're gonna gain back. Now we have to recreate the cal data folder, and the command for that is down here on this. Scroll down a bit, you see this right here. This is the command to recreate the cal data partition. So we come back here, and we do that, and it's done. So now we're gonna do ubinfo-a again, and you're gonna see now only the board config and the new cal data partition that we've just created. So now that's done. Now we're going to come back over here, and we're going to flash the sys upgrade version of the MR18. Okay, so we're going to flash this now, the sys upgrade version. We're going to uncheck, keep settings, because we want it to blow out all the settings, and we're going to flash image. And going to say proceed. And looks like our serial got disconnected. Our SSH session got disconnected, and we can see our serial is going along well. So the boot is booting up. It's looking good. Let's wait for this to complete. And hopefully we'll be able to log in. Hopefully it'll refresh. Let's force it to right now. Force it to refresh. There we go. And log in as root. And now if we go to the system software tab, you're going to see almost 100 megabytes of storage. If we didn't do that step we did earlier, you're going to see around 50 megabytes. But since we cleared out all those unused partitions now we have nearly double, nearly 100 megabytes. And that's pretty much it. That's how simple that is. Okay, so now I'm going to demonstrate how to debrick your MR18. To do this, I'm going to be purposefully bricking my device by erasing the entire contents of the NAND. Okay, so like we did before, I'm going to get ready with program. Currently my Meraki is off, and I'm going to plug it in and be ready to hit enter. Plug it in and I hit enter and it stops, and now we have trap on. So now I'm going to do detect and see if it was detected. So it was detected successfully. So now I'm going to go to all flash and I'm going to hit erase. This is going to erase all of the NAND. And now what I'm going to do is I'm going to reboot the device, and you're going to see that now it's completely bricked. Okay, so I plugged it all, unplugged it. I'm going to plug it back in, and you can see, boom, you get this, error or whatever it is, so you know for sure that my Meraki is completely bricked. Now to unbrick it, I'm going to be using the file that I backed up earlier. You can either use the original, the full flash image, or I could just use the boot.bin. I'm just going to use the boot.bin right now. So I'm going to select the boot tab, and I'm going to open. And first let me do something. I need to, since I powered it on, I got to do program again, and I have to detect. See if it detects now. Yep, and it's successfully detected the chip. So now I can program the boot to it. Since let me do a read, and just to prove to you guys that it's completely bricked. You see, there's nothing, absolutely nothing but F's, all zero. It's white. So I'm doing a read right now of the boot sector. You're gonna see there's nothing so far. There's nada. Nothing. It's finding nothing. So there you have it. It's completely bricked. You see it red, back, nothing. Okay, so now I'm going to load just the boot.bin, which is this section. Everything else is still blank. So I got the boot.bin. Now I'm going to slow program. There's no GUI button for this, so you're going to have to type this. You're going to have to type SPROGRAM. You can type SPR and hit tab to auto-complete that. And you're going to say, first I'm going to erase boot again. Erase boot. So erase starts, and I think it finished. Let me go to output. Yeah, erase time. Yeah, okay. So now I'm gonna program, slow program, and I'm gonna program boot. And this is gonna do a slow programming of the file I just loaded here, the boot.bin. Then I'm gonna, after this is done, okay, now it looks like it's done. I'm gonna do a verify, but instead of a regular verify that you do up here, I'm gonna do a CMP RAM, which is a slow compare. CMP RAM is verify. So I'm going to do a slow verify of boot, and it's going to read the boot sector, and it's going to compare it to what I have loaded right here. And if it matches, it's going to say verified. If it doesn't, it's going to say failed. Okay, so it's reading what's flash. It's not reading this. It's going to compare it to this, and it's going to tell us here if it verified successfully or not. And you're going to notice you're not going to get any trap on while the thing is bricked. You're going to have to actually flash the bootloader first. Okay, it's almost done, and data is okay. So yeah, I compared it, read what was written, and it compared it to this, and it said it was okay. So now what we're gonna do is we're gonna unplug this, and we're gonna reboot it. And let me get ready with program, and hopefully we get the trap on. We're looking for trap on, not debug on anymore. So we go program and get ready, and I unplug it, and I'm gonna plug it back in, hit enter, and we got trap on. Perfect. Okay, so now we can proceed to program these other sections. So I'm going to go to all flash, and I'm going to load that full flash image that I copied earlier, and then I'm going to go one by one and program each and every section, because normally you can just do a write and it's going to program the entire flash, but since the NAND flash is 128 megabytes and the memory that the router has is also 128 megabytes, it's gonna fail. So that's the reason he split UBI 1 and 2, because they're fairly large, and he split them in two different sectors, so you don't have any problems programming the the flash, because if it's too big it's gonna fail. So we're gonna program the boot first. So we're just gonna click on the boot menu, the boot tab, and we're gonna click write. Are you sure? We're just rewriting it for good measure. Now we're gonna go to kernel 1. We're gonna write that. We're gonna do the same down the line. We're gonna do kernel 2, and we're gonna do UBI 1 and UBI 2. And after that, we're gonna go to all flash, and we're gonna click verify, and we're gonna make sure everything is exactly like we loaded. Okay, kernel 1 is programmed. Now that's finished. Now we go to kernel 2. We write. Finished. Now we're going to do UBI 1 and UBI 2. These are going to take a bit longer, so I'm going to start this, and I'm going to come back to you when UBI 2 is finished. Okay, so I'm going to write UBI 2, and I will be back when I'm done with UBI 2. Okay, so UBI 2 is about to finish writing. I want to talk to you about debricking. Everybody is going to have a different problem. If you've bricked your device using serial or shorting the pins or whatever, you may need somebody to donate, a bootloader or a kernel or I don't know, even maybe somebody to donate their UBI section, which is going to contain their Macs and serial and whatever. So maybe you want to know how to make those generic, or make those match those to the person you're donating your flash to. So okay, right now I'm gonna do a verify of all the flash, everything I've written. So I'm gonna compare everything against what I have loaded right here. So this is gonna take about 10 minutes. Okay, so data verification is almost complete. There it is. Let's check. The data was okay. So now we have a fully, restored, unbricked MR18. To verify that, I'm going to unplug it. I'm going to plug it back in. And we're going to see it start up. Thing looks normal. Got Meraki console. And looks like we're golden. Go here, and yeah, so we're back to original firmware. Of course, you guys can go back to original your your OpenWRT build. You know, you can take a snapshot of that after you complete, you know, doing all those steps that I showed earlier. I guess that's it.